Now, RDDs, broadly speaking, are collections of data. They're divided up into records, and the format of those records can vary. But a pattern emerges that key value records seem to be especially important. They're so important they have some special APIs associated with them, and we give them their own treatment in this module. We're going to dig into some of the operations you can perform on pair RDDs and the APIs you use them, and explore some interesting use cases for pair RDDs. Now, in general, RDDs are collections of records, and the stuff inside that record can vary. We do find, though, that key value pair RDDs sort of emerge as a common pattern, so much so that they get their own treatment. They're kind of their own thing. They're called pair RDDs. They have their own APIs and apply to a few important use cases. Now, the structure of the key, the structure of the value, those can vary. We generally think in trivial examples of the key being a string and the value being an int or something like that, but they can be complex and even custom data types. We'll take a look in this module at the various APIs we use to deal with pair RDDs and some of the kinds of problems we can solve with them. Some of the operations we'll perform on pair RDDs will be the things you see here. We'll be able to aggregate, group, and sort in interesting ways. We'll be able to do inner and outer joins, just like in a relational database with pair RDDs. And we've got some set operations like union, intersection, and difference that we'll explore as well. Now, this is not to say that pair RDDs don't support the kinds of transformations and actions that we've already covered. They absolutely do. Things like map and filter and collect, those are all things we can still do on these. We just get a few extra features thrown in. Let's cover a few obvious examples. These are the keys and values transformations. If I have a pair RDD, which is a collection of key value pairs, and I call the keys transformation, I'm going to get a new RDD consisting of a collection of just the keys. Likewise, if I call values, I'll get a new RDD consisting of just the values. Of course, you might imagine how you could perform those same things using the map transformation. That wouldn't be an anti-pattern or anything like that, but as a little bit of syntactic sugar, keys and values are here for us to use. Now, map values is another thing that we could implement with map, but in this case that is considered an anti-pattern. If you want to perform a transformation on the values of a pair RDD, but leave the keys untouched, then you definitely want to use the map values transformation. That's going to leave the keys the same. This will allow the new RDD to be partitioned in the same way as the old RDD. The framework is able to do a little bit of optimization there. So if you're trying to map just the values, definitely call map values. Don't use map, because that potentially, as far as Spark is concerned, could disturb the partitioning of the RDD, and we'd rather not do that if we don't have to. Now, if the values are a collection, or if our mapping operation is going to return a collection of things, then we can use flat map values. That implicitly is going to turn the value that it's mapping from each pair RDD record into some sequence of values and emit it to the destination RDD. You can see in this simple example, we are mapping the values of that source RDD and just giving everybody a birthday. Everybody's age is incrementing by 1, assuming that value is an age there. A couple of interesting actions that we can use on pair RDDs. First, there's lookup. Lookup, we're going to give a key, and it's going to return to us a sequence of all of the values in the source RDD that have that given key. It's as if we're looking up the values in that RDD for that key. And that is an action, so that's actually going to return that sequence as sort of a result of the computation. Then we have collect as map. Now, collect, we've seen before on RDDs. Collect takes all of the records in the RDD and sort of returns them as a sequence back to the driver program. Collect as map, since this is a pair RDD, is going to do that same thing, except instead of just a collection, it'll be a map, and a pair RDD maps onto a map. And of course, pair RDDs translate into maps in a fairly intuitive way. So that action makes a lot of sense. How might we apply these? Suppose we wanted to find all the ratings of the movies in our database released in 2014. Let's take a look at the code. The top couple of lines ought to look fairly familiar at this point. We're querying the movies table in the Killer Video namespace, and we're selecting just release year and rating. And that's going to give us a tuple. We're asking the driver to give us a tuple back containing the release year and the optional float rating. Then we'll map the values of that pair RDD, replacing unrated films with a rating of 0. Then we'll look up all of the keys that have the value 2014, returning those to the driver, iterating over that collection, and you've got the for each print line To print them out, we see the answers are 6.3, 6.0, and 5.4. We didn't ask for film names in this example, so those are just the ratings. We could use this to get an idea of how well film is doing in a particular year, and this query would give us that sort of data.